Okay, am I live? Let's see. Question right one. Wait here. Okay. Okay, am I live? Let's see. Question right one. Wait here. Okay. Okay, am I live? Let's see. Question right one. Wait here. Okay. 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 Hello. Okay. Okay. So today we are again back with another video, and in this video also we will be going to solve eight code questions. This is day two. I don't know why it is say day one. Day one is already over, bro. Say day one is there. It should be day two. Okay, I will change it later. Let's solve some lead code question. And for every lead code question, I will give myself only 30 minutes. Okay. And if it is not possible to solve in 30 minutes, then I will move ahead with the next question. Okay. So let's see. Okay. The first question of today is this. Let's see. Okay. This is a hard, like, doesn't matter, right? I can solve it. Okay. Okay. Let's start the timer. Okay. So you are given an undirected graph. You are given an integer n. Okay. This is the number of nodes in the graph. Okay, fine. And the array edges where each edge UI indicate okay, there is a unidirection. Unidirection matlab in both direction, right? Okay. So a connected trie is a set of three nodes where there is an edge between every pair of them. Okay. A connected trio is a set of three nodes. Okay. In which there is an edge between every pair of them. Okay. So all three of them should be connected, right? The degree of connected trio is the number of edges where one endpoint is in the trio and other is not. Okay, return the minimum degree of a connected trio in the graph or minus one if the graph had no connected trios. So what they are saying is the degree of connected trio. Okay, for example, this I can see a connected trio. So the degree of this trio is the number of edges where one endpoint is in the trio and the other is not. What that what is what is this mean? Number of edges where one endpoint is in the trio and other is not. Let's see. There is exactly one trio which is okay. The edge. that form its degree are bolded in the figure above. Okay, this, and this. Okay, beside these. Okay, where one endpoint is in the trio and other is not. Okay, okay. So the degree of this trio is the whatever beside these degree. Okay, for this. Okay, this. Okay, this. Okay. So we have to return the minimum degree of a connected trio in the graph. Okay, and this is unidirectional, right? Unidirectional or bidirectional? Mm, it says undirected X. Okay, it is not directed. Okay, okay. So we have to find a trio so that they should have every pair. Okay, hmm, and we have to calculate the degree of the trio. Degree of the trio can be calculated by checking the three of them. Okay, fine. And we have to find the minimum one. Okay, for example, here the degree is 3. Okay, here the degree is 0. Here there are how many? One is this one and one is this one, right? So this one has a degree of 2 and this one also has a degree of 2. So why does it return 0? What? Why does it return 0? Return the minimum degree of a connected trio in the graph. Okay, this one has a degree 0, right? Okay, okay. Alright, alright. So what we are going to do is in this question, let's check the how many nodes are there. Okay, so 400 nodes are there. Okay, there are no repeated edges. Fine. See, we need to find three what three nodes, right? So I mean I can check for every pair, right? I can create a I can write a loop for every trio, right? Suppose such as 1 to 1 to 2, sorry, 1 to 3, 1 to 4, 1 to 5, 1 to 6, and check, right? The time complexity will be n cube, so it will be 10 to the power 6. That is fine, that is acceptable. And for that every pair, we need to find the degree, right? First of all, we need to find whether they are connected or not, right or not? Yes. So what I need to do is, uh, okay, okay, okay. So I need to check for every trio. Okay. Should I create a adjacency matrix or list? I think I should create what are the edges here? 1 to 2, 1 to 2, 1 to 3. Okay. I think I should create an adjacency matrix because when suppose this is the trio 1 to 3, right? Now I need to find whether there is edge from 1 to 2 and 1 to 3 or not. If I create an adjacency list, then it will take a linear time to check. So if it is an adjacency matrix, then it will be in big of one time, right? So what I will do is, first of all, I will create an adjacency matrix. So vector, it will be a 2D vector, right? Of let's just say matrix. The name of the matrix will be ADJ matrix. Okay. Uh, it will be n plus one because n represents 6. 0. Okay, it is from 1 base now. Okay, so n plus 1. Uh, Another vector n plus 1, and initially all of them will be having 0. So what I will do is for every edge I am getting from edges, I will fill these edges uh, in the graph, right? So what I will do is first of all I will let u will be edge of 0, v will be edge of uh, 1. Okay, and what I will do is I will mark this in adjacency matrix that from u to v there is an edge. Also from v to u there is an edge. Okay, so now my adjacency matrix uh, what do you say is completely filled. Now what I will do is I will create a variable which will store the minimum degree. Okay, initially it will be it max, right? So what I will do is for I will now check for every for integer I equals to n I plus plus. Okay, for integer j equals to 0, j less than n, j plus plus. Okay, and for integer z equals to 0, z less than n, z plus plus. Okay, okay. Now there is a issue here. So if I is equals to j, then I shouldn't continue with this pair. Okay, and if j is equals to z, I shouldn't continue with this pair. Okay, now it is fine. Now what I have is I have three nodes. Okay, I, j, and z. Now I need to find whether first of all they are trio or not. Okay, so I have three nodes. They are basically I, and it should be not from 0, right? Because nodes are from 1. Nodes index start from 1, right? Okay, and it should be equals to n. Okay, now it is fine. Now I have three nodes. I want to check whether uh, they are equal or not. Okay, so what I will do is I will create a flag variable. Initially it will be true. Okay, whether this flag represent whether they are try or not. So what I will do, I will first check for pair. I will first check whether I is connected to both of them. Okay, so I will check if adjacency matrix of let's say sorry ADJ matrix of I and J. Okay, if it is sorry, what is this? Wait a second. Okay, okay, I can find it. Uh, okay, if I is not connected to J, or ADJ of matrix of sorry, what is this? ADJ of matrix of I and Z is equals to 0, then I should say that flag equals to false, right? Okay. Now similarly, uh, let's check for the J, right? I'm checking. Initially, I check this one is for whether this is connected with these two or not. I'm checking whether this is connected with these two or not. Okay. Okay. Now I'll check whether Z is connected with these two or not. Z and G. Okay. So if flag is false, right? That means this is not a trial, so I shouldn't continue. Okay, now the problem arises. Problem arises, okay, I understood that these three are trial. Now I need to find the degree, right? I need to find the degree. Okay. So one thing I can do is here, I can do here is that suppose for this I need to find what are these edges. Okay, what are the number of edges where one point is in the trio and other is not. So here, as you can see in the trio, you know if it is in trio, then its degree will be minimum will be 2 and maximum can be anything, right? So what I will do is I will create a vector array, okay, which will represent the in degree of the nodes. Okay, there will be n plus 1, sorry, n nodes, and initially all will be 0. Okay, let's create it then here. And whenever I am filling, I will say that in degree of this node plus plus. Okay, also I will say in degree of b plus plus, right? Did I write it? Okay. So suppose there is a node 1 to 2. So I will say, okay, the in degree of 1 is 1 and in degree of 2 is also 1. Okay, this edge. Now if I 1, 3, okay, in degree of 1 is 2. Okay. Now, now my current trio degree will be nothing else than in degree of I minus 2. Why minus 2? Because if it is in trio, then I should remove these two edges from this, right? Plus in degree of j minus 2 plus in degree of ijz minus 2, right? And this is my current trio diary and I will store it in my answer. That is minimum degree will be minimum. I need to find minimum of x. Okay, minimum of itself or current trio degree. Okay, fine. And in the end, I will check because there may be a possibility that there is no trio, right? So I will check whether the minimum degree is int max or not. If it is int max, then I should return minus 1 or else I should return the minimum degree itself. Okay. Hmm. Okay. In degree. Okay. I knew there is some. Okay. In degree. Let's see. Okay. Case is getting accepted. Let's submit it. I don't think so. There should be an issue. Time limit exceeded. Time limit exceeded. Okay. Shouldn't we exceed, right? 400. Uh, this is 100 cube. 10 power 6. Hmm. The same time limit exceeded. Okay. How many test case passes? 65. Okay. I think, what? How can we improve the complexity of this? We are checking for every pair, right? We can also do like if in degree of this node is less than 2, then I shouldn't continue with this pair, right? I mean, I can improve like this. Okay, maybe it will get accepted. In degree of this J, Z. Let's uh, use this test case. Okay, let's run. I mean, in this way we can improve. Uh, okay, submit it again. Hmm. Okay, still okay. What is wrong? It is going n cube, right? N cube, 400 cube, 400 cube. How much is 400 cube? 1, 2, 3, 4, 5, 6, 7, 8. Okay, it is 8. Okay, okay. Hmm. What should I do now? Connected trial. Hmm. There's other way. I don't know. I thought n cube will get accepted, but it is 400. So it also not get accepting of 300, right? Hmm. So if n cube is not getting accepted, then what should I do? Okay, for example, if I'm setting a node 1, maybe n square. Suppose I'm at here, but still I'm looking for every z, right? Hmm. Or should I do something else? I know that one is connected to 2, 3, and 4. So what I will do is I will check which 1, 2, okay, 3 pairs. Hmm. Uh, okay, maybe there may be a duplicate pairs, right? Suppose 1, 2, 3, and 3, 2, 1. 1, 2, 3, 3, 2, 1, 2, 1, 3. Okay, but I don't. Do I need to store them? No, no, no. Nothing. So I need to do. Hmm. 1, 2, 3, 4, 5, 6. Okay. Now what should I do? If I ignore this solution right here, right, and think about new solution, then what should I do? I'm thinking of removing this extra loop. This ij is fine. I think I should remove this extra z loop, right? So I'm no okay. I will check whether these two are right. Okay, these and these two should have a common, suppose these two. Okay, these two should have a common element. Then I will know for sure that these are trial. But still I am looking for all the pair. Suppose one is there, and two is there. Oh, let's see. Uh, one is connected with two. Okay, four and three. Okay, let's see. I know one is connected with two. So what I will do is I will search for a pair. Hmm. Okay, instead of going n, should I go to n by 2? No, n by 2, n by 2. Mm, I is 1. So 1 till n, that is 1 till n. What if I do like this? I and j. I'm saying that I will always be maximum, j will be the second maximum, and z will be the third maximum. In this way, I can remove some time complexity. Okay, now it is 251 ms. Let's see now. Okay, now it get accepted. Okay, so what I did here is I noticed that I'm looking for every pair, right? 1 till n. If I is 1 till n, j is again 1 till n, z is 1 till n. So I noticed that there will be some pairs that will be same, right? Just suppose this one is try, right? Suppose 1 to 3 will be a pair, 3 to 1 will be a pair, 2 1 3 will be pair, 2 3 1 will be pair, right? So it is not because and we need not to calculate for every pair, right? Because these all are the same trial. So what I did is I said that okay, I will represent whatever is the maximum of the trial. Maximum of the trial is 3, okay? J so and J will go till I. Okay, J will go till I. So J will be the second maximum and Z will go till J. So Z will be the third maximum. So I will in a trio, I will be the most maximum here 3. Z will be the second maximum, that will be 2, and Z will be the third maximum, that is 1. This way there will always be a one pair here calculated. Okay, I have 4 minutes left. Okay, no worry. Hmm. Submission 10 minutes. Okay, sorry. Let's check n cube adjacency list versus matrix. Hmm. Yeah, bit set. Thinking about this problem. Okay. Yeah. Okay. Let's reset the timer. Another solution. Hmm, okay. Okay, NQ is the massive, right? Yes, I told you that adjacency list will not be good way to solve this problem. Adjacency matrix will be right faster. Hmm. Yeah, okay. Yes, yes. I think this is also what happened, right? Although my code is looks ugly, but okay. Yeah, so I did this. Let's move to the next question. Okay. Let's start the timer. Let's first of all watch the screen. Although my code is looks ugly, but okay. Yeah, so I did this. Let's move to the next question. Okay. Let's start the. Okay. Next question is okay. Time start. Okay. The beauty of a string is the difference in frequency between the most frequent and the least frequent characters. All right. The beauty of a string is the difference in frequencies for most frequent and least frequent characters. Okay, fine. For example, in this A, B, A, C, C, A is coming three times and B is coming one time. So 3 minus 1 is 2. Given a string S, return the sum of beauty of all its substrings. Okay, all its substrings. Wait, what? If I want to generate all substring, then wait, what? Return sum of all its substrings. So what I can do is I can generate all substring and take another loop to so 500. What the hell? Hmm. Hmm, hmm, hmm. Okay, so why it is medium? Okay, so what I can do is I can generate all possible substring. It will be in n square. Now to find the what most frequent and least frequent characters, what should I do? I can write another loop, but it should not be feasible, right? What I can do is while creating a substring, while generating all substring, what I can do is I can maintain a frequency array and a maximum and a minimum frequency, right? And while generating all the possible substring, I will update them one by one. And okay, yes. So what I will do is let's first of all take the length. So length. Okay. Also, let's take some zero. Okay. Whatever file integer I equals to I less than I plus or integer j equals to 0, not j less than nth j plus plus. Okay. Start for I. So what I will do is, suppose I'm starting from here, right? I will generate all the substring that start from here. So what I should do is, for every starting point, I should have a frequency array of 26 characters and the frequency of this current, but current, sorry, what is it? S of I minus A should be 1, right? And I should have maximum, uh, which will store the, what do you say, which will store the maximum frequency, and this will store the minimum frequency. Okay, so I don't think I should go with I plus 1, right? Because a single string will have a substring of 0, right? Okay, I plus 1. Okay, so what I will do is, first of all, I will, sorry, I will include this in my array. Now maxi will be maximum of maxi itself and the frequency I just updated, right? And minimum should be 1, right? Uh, minimum should be 1. But if okay, maxi I can see. Uh, okay, what about minimum? Maxi I can see. Okay, suppose some character 3 times update, then it will be issue, right? What about mini? Mini, uh, mini should not have. Mini will not be always 1, right? Suppose in this case, uh, let's say this AAB, right? So here minimum is 1, maximum is 1. Okay, mini should be minimum of what do you say, frequency, sorry, frequency of this ith character and the frequency of we just updated. I think so. Yeah, is it right? And in the last sum will be nothing else than xc minus mini. In the end, I will just return sum. Is it good? Me. Let's driver. Driver question. Let's say okay, greatest thing. B C B. Okay. So first string is A. The frequency of A is 1. So maxi and mini will be always 1. So it will be 0. Let's say A. So frequency of A gets updated to. So maxi will be also 2. Minimum will be also 2. So again 0. Let's say B. So the value of A is 2 and the value of B is 1. Right? Now maxi is 2 but minimum is 1. Good. B, C. Okay. Now value of C is 1. Okay. And it should mean frequency of S of I minus. I think there is some issue in minimum because what we need to find is, okay, wait a second. Uh, for minimum I can iterate in the whole array, right? Yeah, it will be 26. So I think it should not be issue and it shouldn't be 0, right? So what I will do is, so mini, what is mini? For it is sorry, that equals to, sorry, z equals to 0, z less than 26, z plus plus. If frequency So frequency of z is not equals to 0, then mini will be equals to minimum of mini itself and not mini itself. Uh, mini will be this maxi, right? Mini itself and the frequency of this z. I think now it is fine. Let's run. Cases getting escalated. Let me write another message. Oh my God. I don't know why. What is the issue with this? If it is a single string, then what? Should be zero, right? Okay, the problem arises, I think, A, B, C, D. If there are multiple, then what should be? Okay, it is very simple. Let's submit. Okay, I, I don't think it should be a medium question, but okay. And the time complexity is 500. I think it should be a same one. Okay. Okay, so we solved and comment 10 minutes. Okay. Okay, let's move to the next question. Let me drink some water. Check the stream. I think it should be a same one. Okay. Okay, so we solved and comment 10 minutes. Okay. Okay, let's move to the next question. Let me drink some water. I or not. So what I will do, I will first check for pair. I will first check whether I is connected to. Okay. Okay. This let's see this question. Okay, let's start the time. Okay, you are given two array of integer nums1 and nums2. Okay, fine. So we are given with two integers nums1 and nums2. Okay, possibly of different lengths. Okay, fine. The value in the arrays are between 1 till 1 and 6. Okay, that is something interesting. The values in the array are from between 1 and 6. Okay, inclusive. Okay. In one operation, you can change any integer's value in any of the arrays. In one operation, what I can do is you can change any integer's value, okay, in any of the arrays to any value between 1 and 6. Okay. So in one operation, what I can do is I can choose any array, and in that array I can update the value of any element between 1 till 6, right? In any of the arrays to any value. Choose any integer's value in okay, okay. Return the minimum number of operation required to make sum of values in nums2 equal to the sum of values in nums2. Okay, return -1 if it is not possible to make sum of two arrays equal. Okay, so I should minimum number of operation so that nums1 is equals to nums2. Hmm. Okay, and return -1 if it is not possible. So when it will be not be possible? It will not be possible when suppose nums2 is of length uh, 10 and all of them are 6, right? And this is order length, this is length. Even if I maximize it 6 6 6 6, it will not be able to equalize the sum of nums to it if it is greater than 10 or whatever. So in that case I have to return minus. Okay. And I should have written sorry, but I should return minus. Okay. And I have to return minimum number of operations. Okay. So greedily, if we think, what should we do? I have to return minimum number of operations. So first I will need to find which array has minimum sum, sorry, which array has less sum, right? In that array, only we can manipulate, not manipulate, or either we can increase the sum of the less, sorry, the array which has a less sum, or we can, no, either we can decrease the sum of the array which have greater sum, or we can increase the sum of the array which has less sum, right? In both cases, whatever is the minimum operation, we have to return that. Hmm. Okay, let's take this example. Nums one is what? 1, 2, 3, 4, 5, 6. Okay. Nums two is 1, 1, 2, 2, 2, 2. Okay. Currently, the sum of first one is 6, 4, 10, 20, 21. Okay. Currently, the sum of first one is 21. And on the second array, 2, 2, 4, 5, 6, 7, 8, 9. But yes, the sum of nums2 is 10. So I need to increase the size of the second array by 11, right? Or I can decrease the sum of this. Hmm. I need to increase by 11, right? Okay. So if we want to minimize the operation, what I will do is in the nums2 array, since I want to maximize nums2 array, right? So what I will do, I will choose the minimum element. Minimum element is 1. Okay. What possible maximum can I achieve this? 6, right? So what I will do, I will remove 1 and I will insert 6. Now the sum gets increased by 2 to 4, 5, 6, 7, 8, 9. Now the sum gets increased by 15. Okay. Now the difference is 6. Okay. Again 6. Again I will choose the minimum element 1. I will maximize it. I will push 6 in it. Then it will have, now the sum becomes how much? I think it will be 20, right? 2 to 4, 5, 6, 7, 8. Yes, sum will become 20. Okay. Now I just need one, I need to increase by 1, right? So I will choose 2 and I will just make it 3. Now the sum is, so by doing this, we have only 3 operation. And okay, 3 operation is okay. Yeah. Should I do it like this? I think I should do like this. But I'm thinking of the case that there may be a case where reducing the sum of nums2 will be a better solution. Hmm. Or not? I don't think so. Reducing the sum, yes, yes, there will be a case, right? Suppose nums2 is how much? Nums2 is of length 2, okay? And both of them are 6, so sum is 12, right? And we have nums1 with, let's say, 6, 6, and sorry, 6, 5, and let's say 6, 4, and 5, okay? 5, 4, 9, and sorry, 15, okay? Sum has 15. So nums1 is 6, 4, 5, and nums2 is 6, 6. So nums1 has a sum of 15 and nums2 has a sum of 12. So in this case, I cannot increase the sum of the array which has less sum, right? Because it is already maxed out. All of them are 6. So I cannot uh, increase the increase the sum, right? So what I need to do is I need to reduce the sum of the array which has greater sum. So nums one should be reduced. So what I can do is I need to make 3. So I will do this 3 or 6, 5, 11. I can make this one. So instead of 6, 4, 5, what I will do is I will make it as 6, 1, 5. Now the sum is 12. Yeah. Hmm. Okay. This I think is good question. Okay. Nums one, both of them are 10 to the power 5. Okay. 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 I should think something else. I need to what my aim is. I need to uh, make the sum of both the arrays equal, right? Okay. Okay. I need to make both of the sum arrays equal, right? Hmm. Hmm. So what I can do? Hmm. Okay. 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 So there will be two cases. Either I will reduce the sum or I will increase the sum, right? So I need to think about the both cases. Okay. Hmm. So okay. What I will do is uh, value in nums of I is okay less than 6. Okay. So it will be, but why it is less than 6? There should be a question here, right? There should be something interesting to this. Nums of I is less than 6. Why they have chosen till 26? Hmm. Okay, let's someone sorry someone equals to 0 and sum 2 equals to 0. Okay. Now for auto represent element in nums1, sum1 plus equals to element. Okay, for auto represent element in nums2, sum2 plus equals to this element. Okay. Now I need to find which one is maximum, which one is minimum, right? Hmm. If sum1 is greater than sum2, else if sum1 is equals to sum2, then I should return 0, right? Because there is no need to change. Else, okay, else it is this. Okay. Hmm. So here we have two options. Either reduce the sum or increase the sum. Okay. For reducing the sum, what I will do is I will first of all sort the array. Should I sort this? Yes. Sorting will definitely help us. Okay. So if you want to reduce the sum one is greater, right? So I need to remove from array 1. Okay. Suppose sum is 12, 15. You need to first of all calculate the difference. Difference is how much? Sum 1 minus sum 2, right? So I need to maintain this difference. Okay. So what I will do is I will iterate for integer j equals to what is the size? Yes, integer n equals to nums1 dot size and m equals to nums2 dot size. Right? Okay. So I will start from the last index, right? So n minus 1 till j is greater than equals to 0, j minus minus. Okay. So what I will do is, okay. So last element. Okay, I need to find the minimum operation, right? So suppose last element is 5 and I need to, uh, okay. So if, uh, so maximum I can reduce is, maxi reduce, how much? Will be v of j, whatever, whatever this is. Okay, okay, okay. Where was I? Okay, so what I'm doing is I'm iterating from the last index, okay, and I'm thinking that what is the possible maximum reduce I can do. So if it is 1, then I cannot reduce much more than that. If it is 6, the maximum I can reduce is by 5 units, right? Because 6 can be reduced to minimum 1. So I can reduce maximum 5 sum. sum of 5. So I'm checking. This is the maximum radius I can do. If difference is greater than maximum radius, so what I will do is I just reduce the maximum. Okay, and I will increase the operation. Okay. So what happens if difference is greater than it? So wait a second. Hmm. Okay. Go ahead. Let me start that. Uh, Operation plus plus. Hmm. Okay. When should you stop if difference is greater? Okay. Uh, Suppose if difference is less than, right? Uh, Suppose I reduce it, and if the difference get maximum, okay, I will reduce. Suppose the difference is 10, and the maximum I can reduce is 2. Okay, I will reduce 2, then it will become 8. J gets decremented. The minimum I can reduce is 2. Again 2. Okay, okay. And in the last, suppose the difference is 3, and the maximum I can reduce is, let's say, 5. Okay. So in that case, what I will do, I will just subtract. Okay. So, okay, I'll just subtract it from this. And what I will do is operation, after increasing operation, I will check whether if difference is less than 0, that means it is already done and operation is successful. Okay. Okay, I think this is fine. We have less time. Okay, difference is somewhere. Okay. So this is the, and if difference is still positive, difference is less than or equal to 0, right? If difference is less than equal to 0, okay. If the difference is still positive, that means we couldn't do this from this variable. Okay, let's again initialize the variable difference as sum1 minus sum2, right? Now, now I will increase the sum. So I will start from the second array. Okay, oh sorry. This should not be b of j. What I'm doing is I should go with nums1 of j, right? Okay. Now I will increase the sum of the nums2. I will start from 0 and I will go till n. Sorry, n. I plus plus. Okay. Uh, okay. I 0, I less than m. Okay. So maximum increase. This represent the maximum increase I can do. So maximum increase will be nothing else than 6 minus nums2 of I. Okay, so if it is 6, then I cannot increase maximum. If it is 1, I can maximum increase 5, right? So if difference, suppose difference is 10, again, what I will do is I will subtract difference maximum increase, okay? And okay, let's name is operation 2. Operation 2 equals to 0. Sorry, yes, operation 2 equals to 0. And I will increase the operation 2. And if any moment difference is less than or equal to 0, I will just break it. Okay. Okay. One thing I can do is if difference is still greater than 0, I will operation will be in max. So that I will not take this. Okay. And still if difference is greater than 0, I will say that okay, OP2 will be int max. Okay. Uh, let's take our answer here. Integer answer will be initially int max because we need to find the minimum number, right? Uh, so minimum, sorry, answer will be equals to minimum of mini, eh, sorry, answer OP and OP2, right? Okay. And okay, let's one thing, let's not just write the written answer. I'm not writing the second case. Let's check for this. This sum has a greater, right? So let's remove this, remove this. Okay, let's see whether this is giving correct answer or not. Okay, this is giving correct answer. This is 1, 2, 3, 4, 5, 6, 7. Okay, this has a greater sum. Okay, this should also 6, 6. This has also greater sum. Okay. Okay. If answer is it max, then I should return -1 else answer. Hmm. Okay, case 3, it is giving me, you can make this one 3 operation. Okay, okay. Hmm, I didn't think of it. Wait a second. I think I think I should use binary search in this question. No, I think so. So the minimum sum will be 1 because we want to equalize, right? So suppose I get a sum 100. I want to say whether I can make them 100 or not. If both of them are 100, I need to minimize the sum, right? No, not binary search. Okay, this one is some issue, right? Because this is a sum of 1. Okay, it will not work if I am reducing this, then it's also not possible. If I increase this, then also it is not possible. Here, both operations are happening on the both arrays. That is something new. Uh, what should I do? See, hmm, um, hmm, hmm. Okay, one thing I can do is here, since I'm reducing the sum and still uh, it is not possible, then what I can do is I can increase the sum of this, right? Here it is increasing, right? Hmm. Let's just comment it out. OP. Let's comment it out. OP discuss. Let's comment it out. Okay, so what I'm doing is I'm reducing the sum, right? I'm reducing the sum, uh, and then what I'm doing is I'm also increasing. Okay, I'm reducing the sum. All right. Sorry. Yes, and difference is still less than equal to then right. Yeah. Okay. So what I will do is I will first let's just comment. Sorry. Here, if it is still greater than zero, let's do something else. Okay. Let's just copy this and paste it here. So what I'm doing is I'm reducing this. Okay, I'm reducing the sum, and if it is still greater than zero, that means I should maximize it, right? Now I should increase the nums too. So I'm going to difference maximum increase, and it should be OP plus plus. And if difference is still greater than zero, then OP should be int max. Okay. Now same case here. OP2, OP2. Okay. If difference is still greater than zero, then what I will do is I will copy this, right? After increasing the sum, still it is not possible to do that, right? After increasing the sum of nums 2, still it is not possible. So what I will do is I will start by reducing the sum, and this will be OP2. Okay, okay, OP2 plus OP2. If difference is greater than zero, okay, break. Where it is after this loop, if difference is still greater than zero, then what I will do, I will say so int max. Okay, now I think it should be fine. Okay. One thing I can do is instead of this and this, let one thing. So let's say someone is always greater, right? So what I will do if sum 2 is greater than, sorry, if sum 2 is greater than, sorry, sum 1 is less than, right? So what I will do, I will swap nums 2 with nums 1, and also I will swap it sum 2 with sum. Can I swap vector? I don't know. Hmm. Okay, moment of truth. Submit. Error. Around this case. Output is 7, expected 4. Hmm. I think it should be something else. I kind of think it is of DP, right? For every place there is 6 position. I don't know. Okay. Hmm. Fine, fine, fine. Okay. Okay, time is over. Let's move to the next question. This is the next question. Check the stream. Next question. This is the next question. Check the stream. Next question. Okay. What the hell is this? Okay. Hmm. Let's start the timer. Okay. There is a school that has classes of students. Each class will be having a final exam. You are given a 2D integer array classes where classes of I is pass, and you know beforehand that in the ith class there are total as student and but only pass number of students will pass the exam. Okay, so total there and only these many will pass. You are also given an integer extra student. There are another there are another extra student, brilliant student that are guaranteed to pass the exam of any class they are assigned to. Okay, okay, guaranteed. You want to assign each of the to class in a way that maximize the average pass ratio across all the classes. Okay, the pass ratio of class is equal to the number of students of the class that will pass the exam divided by the total number of students of the class. Okay, the average pass ratio is the sum of pass ratio of all the class divided by the number of classes. Then the maximum possible average pass ratio after assigning extra to the answer with 10 to the power minus 5 of the answer within 10 to the power 5 of the actual answer will be accepted. Okay, what is this question? Okay, so they are saying that they want to put these extra students somewhere so that the sum get sorry the pass ratio get maximized, right? What is the okay extra student can be 10 to the power 5. Okay, okay. Hmm. 1, 2, 3, 5, 2, 2. Okay, extra student 2. Okay, you can also assign the two extra students to the first class. The average pass ratio will be 3 is to 4, 3 is to 5, and 2 is to 2 divided by 3. Okay. And we want to maximize this, right? So what should I do? If I think of a brute force solution, then brute force would be that either I will give all students to one class, two class, or such that. Hmm. They want to maximize the average pass ratio. What is the average pass ratio? So the pass ratio is the number of students passed divided by total number of students. Okay. 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 And I want to maximize it. See, division by this is all, sorry, this is always constant, right? Because the length will be always same, okay? This sum can, we want to maximize this sum, right? Okay, we want to maximize this sum. Maximize sum, okay. Hmm. Mm, 1, 2, 3, 5, 2, 2, okay, 3 to 4, okay. We want to maximize the sum. Total number of students divided by, okay. Let's just think of something else. If, how can I increase this sum? If I'm giving one to, giving some student, then the denominator is also increasing it because I definitely know that these two students will pass. So this will increment the numerator as well as denominator. Examples, 6 upon 12 and 7 upon 13. Which one is greater? This is 1 upon 2. This is 7 2 7 14. No, this is 1 point something. 0 0.5. Okay. If denominator is greater, so this will be less. This will be greater, right? Uh, so there are extra students. 3 to 4, 3 to 5, 2 to 2. Okay. Okay. Hmm. What should I do? Do. Maybe, but I cannot check for every possibility, right? So there is should be something else. Extra students. These students will go into the classes. We're also given an integer extra student. There are another extra student, billion students that are guaranteed to pass the exam. Okay, so these students will, okay, they are assigned. You want to assign each of the extra students to a class in a way that maximize the average pass ratio of all the classes. Basically, we want to maximize it, right? How to do it? First of all, let's just see what is the initial sum. So 1 upon 2 is 0.5, this is 0.6, and this is 1. So initially the sum is how much? 6, 11, 1.1, and 2.1. Initially the sum is 2.1. Hmm? Okay, after they are given 3, 4, 3, 5, and 2, 2. After this is how much? 3 by 4 is how much? 0.28. 2, 4, 5, 20, 0.75. This is how much? 0.6. This is 1. So increase by 0.25, right? 0.25. Mm, Hmm. Uh, so what should I do? Do, do, do. So if I give the maximum 1 upon 2, 5 upon 5, 2 upon 2. Uh, Wait, how much is this? Is 2.35, right? 2 is 1, 0.5, 2.5. But if I give two students to this class, then it will be 5 by 5, that is 1, 1 plus 1, 2, 2 plus 0.5, 2.5 divided by 3, 0.833. But this is a maximum. What the hell? This is not the maximum. That, okay, oh sorry, denominator will also get incremental. Sorry, 3 by 7. What is 3 by 7? Uh, 3 by 7, 5 by 7. 5 by 7 is how much? Yes, it is this much plus 0.5 plus 1. This is this much 2.21. Oh, this is not the machine. Okay. How can I find them, right? Uh, Maybe I want to maximize this fraction, right? This sum. Maybe take a denominator. Okay, I know that 2, 5, so 5, 6, 7, 8, 9, 10, 11. In the end, there will be always some 2, 5, 4, 9, 10, 11. Right? Maybe I can do something else. And they are not asking for exact. They are saying that answer within 10 to the power minus 5 or the actual answer will be accepted. Hmm. Hmm. What should we do? If I'm increasing the numerator, my denominator is also getting increased. Should I give 1 to everyone? Let's see. 0.714, right? 714 by 5, 0.6. So it is getting incremented, right? By 0.11 something. It is getting incremented. And okay, maybe I now got the idea. 3 to 5, 2 to 2, 1. Let's say the maximum I'm getting is this one, right? No, I want to minimum to maximum. Okay. So maybe I can do is giving, so this is 0.6, this is 1, this is minimum, right? So what I will do is I will do here and 3. So this is how much? 3 6 18 2 20 again 3 6 18 obviously uh, 2 divided by 3 0.666 okay 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 0.6 now what is the minimum? This one is minimum, right? So what I did is uh, 4 divided by 6, it is again 666. Now over into 2 plus 1. This is 2.336. No, this is not the maximum. Oh, wait a second. This is what you see. It is the maximum, bro. The hell? Divided by 2.777. 0.7833. Therefore, this is constant. अगर ये बड़ा होगा तो कैसे let let us do this again. क्या क्या fraction है? This is 1 2 3 5 and 2 2. So what they have done is 3. This is 0.6. This is 1 and this is 0.5, right? They have done what? They have 3 or 4. 3 divided by 4. This is 0.75 and else is same, right? Sum is nothing else than 2.25. Such 2.3, right? And 2.3. Okay. So what I'm doing is and this is the minimum, right? So what I did is 2 comma 3 3 comma 5 2 comma 3 divided by 3 is 0.66. Okay. Not minimum को नहीं देना, मेरे को मैक्सिमम को देना होगा. मैक्सिमम को दिया तो कितना होगा? 4/4. Yes, it's clear, right? जिनका वन है उनमें कभी नहीं डालना. Okay. The one which have a value 1 should not be then 2 0.6 3/5. Like if I 5% 714 कितना increase हुआ है? 0.1%. ये इसमें सबसे ज़्यादा increase हुआ है. 0.5. I don't know about this. Mm, mm. Mm, I don't know, bro. This question looks cringy. Oh, this question looks cringy. What is okay? Hmm. I want to maximize the right. In which case there will be a maximum. 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and 1. 1 should not be difference of ones. There is one difference, there is two difference, right? And if I increment it by 1, then there will always be. I want to greater, no? I want to increase. So if the difference is greater, and I know it is, if the difference is greater, suppose let's say 27 and 5, let's say 60 and 2. What is the difference? It is 58, 50. If I increment it by 1, 3, 3 2 is 6, 1 point 5, 20, point 21, 3. I don't know about this question. Let's move to the next question. I don't want to waste time. Okay, let's see this question. Okay, let's start the timer. Count nice pairs in each. We're given an array nums that consists of non-negative integers. Okay, let us define rev of x as the reverse of the non-negative integer x. For example, rev of 123 is so okay, reverse 120 reverse will be non-negative. So suppose if it is minus 121, then what? Okay, it is always positive. A pair of indices I and j is nice if it is satisfies all of the following conditions. But there is only two. Okay, I should be less than j. Okay, nums of I plus rev of nums of j should be equals to nums of j plus rev of nums of I. Nums of I plus reverse of nums of j should be equals to nums of j plus reverse of nums of I. Written the nice pair of indices. Okay. Okay. There's nothing to worry. 42, 11, 1, and 97. Reverse is 24. This is 11 itself. This is 1. This is 79. Okay. Okay. So suppose this is I. This is 42, right? So now, yes. If I'm considering this I, let's say 0 and 3. Let's say I'm considering this J, right? J is currently at 1. Okay. So it says the nums of J plus rev of nums of I. Okay, this equation is just nums of I plus rev of nums of J should be equal to nums of J plus rev of nums of I, right? This is same as nums of I minus nums of J is equals to rev of nums of I. So, okay, okay. Well, I think some little math, uh, V of I, let's plus rev of V of J should be equals to what? V of J plus rev of V of I, right? Hmm. Now what I will do is I will move this here and it will be V of J, sorry, rev of V of J minus V of J should be equals to rev of V of I minus V of I, right? So for this J, I calculated this. So suppose 42, 11, 1 and 97. Okay. So I'm taking this. Okay. So it says rev of J. Rev of J is 1. 1 minus 1 is 0. Should be equal to rev of I. Reverse of I. Reverse of I is what? 24 minus V of I. V is 42. How the hell it is possible? 0, 1, 2, 3. Oh, sorry. 97. Okay. 42 and 97. So they are saying that 79 minus 97 is how much? 79 minus 97. This is negative, right? So 9, this is 18, 1, 8, 18. And what is 40, sorry, 24 minus 42? This is 8, 9, 10, 11, 12. Okay, okay. Found answer. We just need to manipulate this, right? So let's take a hash map, maybe. Hash map. Hash map. Oh, sorry. Map of integer. And it's long and long and p, let's take a long count. Okay, so what I will do is, oh, I need to find the reverse. How to find the reverse? Is there something I can do? 0 0 0. I can reverse the number. uh, Hmm. Reverse the number. Uh, Suppose this is 120, right? So what is 1? So 3 into, so actually it will be 3 and it comes here 2. So into 10 plus, sorry, 2 into 10 plus, this one 23, 23 into 10 plus 1, 2, 0. So it will be 0 now comes here. 0 plus 2 into 10, that is 20. देखें जरा इसमें कितना होगा. Okay, let's say 102. 102, let's say 2 and into 0. Sorry, 0 plus 20. But there will be an issue when there is some 0 in the right hand side, right? So what should I do? What is the length of ref for enums of 10 to the power 9? So maybe I can convert it into string. It will be of what 9 length, right? Do I need to calculate? Let's see if there are way. Reverse the number. C plus plus. Still, reverse number. So, let go 1 3. We can write again. What is printing? Okay, let's say 180. Yeah, this is printing fine. And modulo 10. What is happening? 20. So that is rev into 10. So पिछला जो था rev plus n modulo 10. Okay, last digit. So last digit is 0. So rev will be 0. This now comes to 10 10 0 into 10 will be 0 plus 2. Yes, know this. Why I don't know. Okay, let's create a vector teaser reverse. It will contain all the reverse of the number. So size and will be the size. Not able to use for integer equals to 0 and less than n I plus. Value will be nothing else than nums of I. Okay. It's here. It's a v. Okay. Not v. It's x equals to 0 while value is greater than 0. Okay, x uh, digit, last digit will be nothing else than value modulo 10. What I will do is uh, x x multiply equals to 10. Okay, x plus this digit and value will be reduced by 10. Okay, and in the last ref of I will be this x. Okay, now done. Okay, now what I will do is initially I will push this map of what sorry, map of what sorry, I need to push reverse of I. Okay, so ref of 0 minus v of I. Sorry, v of I. Oh, sorry, nums of I. Okay, this. Okay, now for every integer j equals to 1 till j less than n j plus plus, I need to find a value. So value is nothing else than long value. Value will be what, reverse of this j minus nums of j, and nothing crazy, count plus equals to mp of this value, and for the next iteration I include this. It should be mp. Okay, all right, and in the end I will just return count modulo mod initialize, let's say integer mod equals to 1e9 plus 7 plus 7. Let's see. Terms of the hell. Okay, getting accepted. I think it should be plus. Let's see. Okay, let's submit it. I think it should get accepted. Yes. All right, all right. Okay, done with this question. Let's take another. This will be the last question again. Yeah. Okay, let's reset the timer. Let me drink some water. Okay, let's start with the last question. You are given three positive integer n index and max, and you want to construct an array that satisfy the following condition. Okay, nums length should be n, nums of I is positive integer, but okay, so it should be a permutation. Okay, so every value inside the nums value should be less than n, should be positive index. Absolute of nums of I, nums of is less than equals to 1. Okay. Okay, so the maximum difference between every neighbor should be at max 1, right? Or equals to. Okay. The sum of all elements of the next does not exceed maximum. Okay, it should be under maximum. Hmm. Nums of index is maximized. Okay. Return nums of index of the constructed array. Nums of index should be maximized. Okay. Of the constructed array. Not absolute of 50. Okay. Uh, the first thing in my mind arises is that what is the initial array? Initial array will be all ones, right? Initial array will be all one. So, in my opinion, the maximum should always greater than n or equal to n. Yes, maximum is okay. 10 to the 1, 9. That is interesting. Index is less than okay. 10 to the 9. Okay. Hmm. Okay. Another thing I noticed is that the maximum value of nums of index will be also less than n, right, or equal to n. No, less than. Okay. So, hmm, maybe I can use binary search for every value. I will check whether this is maximum or not. Let's just say for this, let's took the first example, n is 4, right? So I have four elements and initialize let them by 1. Okay. The current sum is how much? 4. Okay. And they want to maximize, maximum sum can be 6. Okay. And index is 2. 0, 1 based or second based? Okay. 1, 0, 3. It is 0 based index. So I want to maximize this one. Okay. So the maximum it can get is 0, 1, 2, 3, right? And not 0. Okay, 0 is also possible. Okay, so initially let's say all are 0. Okay, all are 0. So I'm saying if I increase, let's say, I want to do a 3. Let's say nums of, in nums of 2, there is 3. If there is nums of 3, then in its right hand side and left hand side will be either 2 or either 3, right? Right. If 2 is there, then what is the sum? 2 to 4, 7. If 3 is there, then also it is not possible. So, 3 is not possible. Let's check for 2. If 2 is there, then in left hand and right hand side, either there will be 2 or either there will be 1. Okay. And we want to what? Maximize, right? So, let's say 2. So 2 to 4, 5, 6. It is 6. So it is possible. 2 is possible. Let's say, okay, okay, this is good. Let's take the next example that is n equals to 6. 1, 2, 3, 4, 5, 6. Okay. Initially, let's say all of them are 0 and I want to maximize what? Index 1. Index 1, right? Okay, this one. 2, 3, 4, 5. I think the answer may depend on index, right? Because in the left hand side, Let's see. Okay. The possible value of 6. Let's say 4. Okay. 4. So 4 is here. Now in the left hand and right hand side, either 4 or 3 or 4 or 3. Hmm. Wait a second. I want to minimize the sum, right? I want to count greater than. So I should choose 3, right? Because I want to sum to be under. So I will choose 3, 3. How much is this one? 3, 3, 6, 4, 10. Okay. For this 3, now here it should be 2. For this 2, it should be 1. For this one, it should be 0. Okay, okay, okay. I got the intuition there now. Now for every index, okay, I got the intuition. Now for every index, I will look uh, the number of elements on its right hand side and the number of elements on its left hand side, right? And while doing binary search, suppose uh, I want to check whether at position index can I include 4. So what I will do, I will place 4 here. Okay. Now I know that in right hand side the values will be like 1 less less less. Why 1 less less? Why cannot I just put 4 4 4 in every place? Because we want to make this array, right? And it should not exceed this sum. So intuition should be like I want to minimize the sum. So instead of 4, we'll put 3, and for the next index it will be 2 and then 1. So it is nothing less than sum of n minus 1 integers. Okay. And similarly on the left hand side, and if the sum does not exceed, then it is possible. Then I look for the maximum value, right? Okay. Okay, okay, fine. So the minimum, it can be 0. The maximum will be n minus 1, right? I don't know. Correct. Hmm. Hmm. Okay. These are what I want to do is answer. See, minimum will be 0, right? So what I will, while low is less than equals to high, I will calculate a mid position for the which I want to find. Uh, Low by 2, okay. Low by 2, fine. Now, now I calculate the mid. Now I want to find the elements on right. I can do it here. Elements on right. So if it is of length, right? So suppose it is of length 0, 1, 2, 3, 4, 5. N is 6 and index is this. So elements on right will be n minus index. Okay, 6 minus 2 is 4 and 1 less. Okay. And elements on right will be, sorry, not right, left. Elements on left will be index minus 1. Not index minus 1. Index. One second. Hmm. I noticed something that is not one to suppose 3, 2, 1. Wait a second. 6, 5, 4. So there are three. So what I will do is I will calculate. I want to reduce. Okay. What I will do is I will calculate 1 till 6. 1, 2, 3, 4, 5, 6. I know this, right? And I will reduce this. So this will be okay. Okay. Now this is the value. This mid is the value we want to put it into the index. So the value on its left hand side will be nothing less than mid minus 1 because we want to reduce the sum, right? We want we thus if we put mid, then there will be a issue that the maximum will sorry the sum of the array will be greater than the maximum. Okay, so let's see. Uh, suppose 3, 4, 5, 6. Okay, suppose the value is 6, right? And in the left hand side there are three elements. Okay, in the left hand side there are three elements. So what I need to do is I need to calculate a sum first of all. Sum of first n natural numbers is n into n plus 1 by 2. Okay. So this is nothing else than, first of all, I need to calculate till here. So sum 1 will be nothing else than value plus 1, value multiplied by value 1 plus 1 divided by 2. Okay. This is still value, but I need to subtract something from this. That will be uh, nothing less than value minus in elements on what the hell, elements on left, right? Suppose 6 is there and 3 less than, so I need to find 1 till 3. Okay, multiplied by same plus 1. Okay, and then divided by 2. Okay, I need to subtract this from some, right? What the hell? Okay, so my left sum is calculated. Now, okay, we need to find the right sum. Let's name this as sum 3, sum 4, sum 3, let's say 4, yeah. Okay. Similarly, on the right hand side, let's say 4, 5, 6, 7, not 4, 5, 4, 3, 2, 1. Okay, same kahani. Instead of elements on left, it should be elements on right, right? Calculated till here, until 4, right? Was 4, 3, 2, 5, 4, 3, 4. Okay. Uh, 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 Elements on right. So suppose there are value calculated 1 till 6. Elements, number of elements on right is suppose 3. So 6 minus 3. So I need to subtract this one. So value minus, okay. Okay, now sum is calculated. Now my total sum will be nothing less than sum will be sum 1 plus sum 2 plus sum, not sum 2, sum 3 plus this mid. This will be the, what do you say, sum of the array. if sum is less than or equal to this max, it means this is possible. So what I will do is, the answer will be now my mid, and the low will be mid plus 1, because we want to now check for the greater mid, else high will be nothing else than mid minus 1. And in the end, I will return this answer. Uh, okay, case is getting accepted. Is there a case I'm not thinking of? Let's say 0, 0. So index value 1, right? Maximum is 6. Hmm, I got the case. And if n is equals to 1, okay, and index is 0, okay. So elements on its right will be 1 minus 1 is 0, and index is already, so elements on its right will be 0, and elements on its left will also be 0. So what I'm calculating mid. Okay, except is 6. But how can it be 6 if n is equals to 1? Num of I is positive integer where I is less. Oh, sorry. Okay, okay, low, not should not max. Okay, sorry, sorry. I thought nums of I should be less than 8. 8 max 29. Mm, should I do this? Okay, that's it. 29 है बता है 8 7 14 5 expected 4 happen number of 8, okay, index is 7, maximum is 14, output 5, expected 4. Index is 7, right? So last index, last elements on its side will be 0, right? 0 1 2 3 0 1 2 3 4 5 6 7 for this index, right? I need to check. Okay, maximum should be 14, output is 5, expect 4. Suppose output is 5, so 5 means I can put here 4 3 2 1 0. So okay, it will exceed, right? 4 5 6 7 8 9 10. 10 plus 15 is 15 is there. Okay, I ignore this part. If the elements on right, or sorry, if elements on its left is greater than sorry, uh, then I don't need to calculate it, right? if elements on left greater than well or equal to well. Suppose here that's 4, 3, 2, 1. Okay, elements on greater then don't need to. Okay, I need to calculate only if it is less than 1. And similarly in this case also, if elements on right is less than the value, then only I need to find it, right? Okay, let's use this test case, run it. Okay, now it is getting executed. Okay, I forgot about that case. The hell, why it is giving wrong answer? Hmm, uh, some three let's made. Why should it give wrong answer? It's again. Let's see. Expected to 1. Maximum is 4. If n is 4, 0, 1, 2, 3, right? Next 0, maximum is 4, output 2, expected 1. So if I put 2 here, then it should be 1, 0, right? So, oh, I think elements of right. Hmm, what is happening? Output 2, expected 1. N is 4. So 0, 1, 2, 3, okay. Index 0, I want to put it here. Maximum I can afford is 2. Okay. 2, 1, 0, okay. What is wrong in this? Maximum is 4, maximum is 3. Output 2 expected 1 कैसे हो सकता है? Okay. How can 1 be the answer here? N is equals to 4, right? What is the condition? Nums of length should be n, okay. Nums of I is positive integer where, okay, fine. Absolute of nums of I minus nums of I plus 1. Okay, yeah, should be less than equals to 1, okay. The sum of all element does not exist, okay. Nums of index is maximized. Wait a second, 2100 is valid, right? Index is 0, maximum is 4. How they are expecting 1? 2100 is valid. 321 is not valid, I know. But if n is 4, index is 0, the elements on its right hand side will be 3 elements. I can put 2 here, right? On that index. Absolute nums of I minus nums of I plus 1. 2 minus 1 is 1. What the hell? 2100. Why it is not? 2100. N is equals to 4. Okay. Index is 0. Okay. This 0. Maximum is 4. Okay. So this is maximum is how much here? 3. Output is 2. My expected, they are expecting 1. Why they are expecting 1? Return nums of index is maximized. Nums of 0. This is possible, right? Why they are? Is it something wrong? Nums of I is a positive integer. Okay, I think 0 is not possible. Okay, okay, I understood. 0 is not possible because they are saying nums of I is a positive integer, so 0 is not possible. So, what we need to do, okay, if elements are less, then it is fine. Else, what I should do is, else, what I should do is, suppose, right one, suppose I need 3 characters. Suppose n is 3, so 3 to 1. Uh, 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 I need to add that sum. How many are extra? Else, sum 1 plus equals to, what? Uh, elements on left, if it is greater, minus 5. Sum 3 elements of 8. Okay, I didn't think of this edge case. Still it is giving expect output 0. No, no, should be wrong. Okay, like this question. Okay, yeah, timer is done. Okay. Uh, which question? Okay, I couldn't be able to solve this problem, right? Let's check the stream. Stream is below. Able to solve this problem, right? Okay, one thing Another thing I noticed is that the maximum value of nums of index will be also less than, right, or equal. Mhm. Okay, let's see this question. So in this question, we my side. Let's go to the discussion. The main idea will be to increment the class which will give maximum property. Hmm. You may think we need to increment the one with maximum difference of b minus a equals a, but it actually not that simple. Yes, I was also thinking that the numerator and denominator difference, whichever has the maximum, like, that should be instead one way to check which one is calculating a divided by a plus 1 b plus, and the one which has the maximum is need to be incremented. Oh, so the main idea will to take one class student out of K and assign it to any other class, and after assign we need to update that class. They will repeat the process till K equals to 0. Okay, okay, okay. Hmm. I should be able to think that. Why did I think of it? Okay, okay, okay. Okay. So what we'll do is, hmm, first of all, uh, this is integer, right? Okay. So what? First of all, I will need a priority view because we want the uh, maximum one, right? So what I will do is for every pairing classes, double u is vector of 0, v vector of 1. Uh, what I need to do is uh, what I will push every index with the array and I will take out the maximum one. Okay, manipulate it and again push back. Okay, okay. So it will be a pair double comma integer. Okay. So what I will do is I will simply push back p2 dot push back set double value will be nothing less than u divided by v minus u plus 1 divided by v plus 1. Okay, and I need not push back, push this value comma the index, okay, which should be equals to 0 and less than classes dot size I plus plus. Okay, and this will be, sorry, classes of I of 0. This will be classes of I of 1. Okay, and okay, now what I will do is integer k will be this extra students. Okay, while k minus minus, what I will what I will do is I will take a pair double integer pair equals to pq dot top, and I will pop it out pq dot pop. Okay, so what I will do is classes of the field of second 0 will be incremented by 1 and classes p dot second of 1 will be yes. Okay, and what I will do is again push back this. Again I will push back this. Okay. Integer I will be nothing, sorry, integer I will be nothing else than sorry, p dot second. So let's say I, okay. Okay. PQ dot push. And in the last, double answer equals to 0. What I will do is for integer equals to 0, I less than n, I plus plus, double q equals to this classes of I 0, double p equals to classes classes of I of 1 and answer plus equals to u divided by v, and in the end what I will do, I'll simply return answer divided by what n. I don't know. Why did I not think of this? Wrong answer 700. Huh? What the hell? I don't know. No. One, two, three, five, four, four. Huh? The hell? Shouldn't be four, four. But what is happening? Oh, okay. Yeah. Uh, all right. How long is the stream? 2 hours. Okay. Let's just end this stream, right? Hmm. Okay.